Hello, my name is Macy Zach, and along with Kishore and Elise, we will be discussing our investigation of Play-Doh resistors. Our initial research question was, can we determine the resistance and/or resistivity of the Play-Doh resistor? And the answer is yes, we can. However, beforehand, we must discuss the main physics ideas we've learned in class. First and foremost, resistance is the measure of the opposition to current flow in an electrical circuit. The units for resistance is volts divided by ampere, which can also be referred to as ohm. A resistor is an electrical component that is used to implement resistance in a circuit. Resistivity is the intrinsic property of a material that determines how strongly it resists electrical currents and can be found using the equation resistivity equals resistance times area divided by length. Finally, Ohm's law, which is very important throughout our experiment, states that electric current is proportional to voltage and inversely proportional to resistance. Thus, the equation given is voltage equals current times resistance.
For our experiment, we needed to create a model that would send just enough energy to the light bulb to make it glow, but enough energy to make the fan spin. Using this idea, we designed our circuit using two resistors. One is a 470 ohmic resistor, and the other being a Play-Doh resistor. And then we used 4 batteries, and we connected those to the wires and connected those to the light bulb and the fan, and used the resistors in certain places to make sure that the light bulb did not receive too much energy. When designing our experiment, we had to place the materials in a given way so that the motor and the light bulb were both working. First, we used 4 batteries to power the circuit. Next, we placed the Play-Doh resistor before the motor as one series, and then we put another resistor, R1, in front of the light bulb for the second series. We measured the values between the motor and the fan after this and in between the light bulb and the rest of the circuit to make sure that they were going to work simultaneously and to make sure that they didn't have enough power. If the Play-Doh resistor was not allowing enough current to go through to the fan, then we reduced it to allow for more energy to flow.
Results. We got our light bulb and fan to both work at the same time by changing the type of circuit, which was initially a series, but then we changed it to parallel. We also changed the placement of the Play-Doh and the ohmic resistor. We also decided to make our Play-Doh resistor shorter so that it would produce more energy through it. And we also changed the number of batteries from 5 to 4. Calculations. For the resistance, we use Ohm's law, which is V equals IR. For the V, we use 0.03 volts, and for the current, we use 291 milliamps. After calculating everything, we got 0.103 as a resistance. For resistivity, the formula is resistance times area over length. So in order to calculate the area, we have to use 2 pi RH, R being 0.5 and H being 0.45 centimeters. So after calculating everything, we got resistivity to be 0.647 ohm meters.
There could have been many sources of error with this experiment, such as the fact that different light bulbs required different voltages in very slight amounts, so if we used a different light bulb, our setup might not have worked. Other errors may have included measuring values of current and voltage, and also the batteries may have decreased capacity that led to lower capacity or lowered the anticipated results. Human error in calculations and wires or misuse of multimeter could have also affected our answers, as well as the fact that the Play-Doh dries out over time, so results could vary depending on if the resistor was fresh or dried out.
All in all, the circuit was functional, light bulb and fan included, regardless of the change in resistor. We found that it is possible to determine the resistance and/or resistivity of our constructed Play-Doh resistor. Using the values that we recorded, including voltage and current from our circuit, we calculated a resistance of 0.103 ohms and resistivity of 0.647 ohm meters. Above all, we found that it is possible to replace a resistor with Play-Doh. Thanks for watching, everyone.